Alright, I have a nice gradient here because the sun keeps bursting onto my window shades. But anyway, we're just gonna work with what we have. Shalalalala, it doesn't matter. YOLO. The content is more important anyway. So let's get started with the video you've all been waiting for. At least I've been waiting for this. Hello and welcome to another Solana tutorial. Today we're gonna talk about transfer hooks with Token22. Because this stuff is exciting. This is probably my favorite extension of Token2022 because it's just so powerful. It's just mind-blowingly amazing. And I might be a bit biased seeing that I haven't actually really worked with this before. But the thing is, this is so generic that you can basically do anything. I mean, really it exists because we don't have interfaces yet for you to create your own token program and have that be used by every application. So for now, you'll have to create a Token2022 SPL token and use transfer hooks to do the functionality that you want to have with your token. So yeah, the idea of this extension is that whenever a token of a certain mint is transferred, another program is invoked via CPI. That's the so-called transfer hook. So there's a hook on transfers. Whenever a transfer occurs, there will be a callback to another program. And that way you can implement custom functionality for your tokens. And that will then allow us to do stuff like really enforce royalties on NFTs, not just with blacklists or whitelists like the PNFTs did, which was pretty much whatever. And you can have your custom authorization logic. You can do all kinds of things, especially when you also combine it with other extensions. I mean, this is just very powerful, and today I want to have a look at it. I tried to make this video before, 5 months ago or so, but it wasn't really ready back then, and so many changes were still made that I decided not to make this video yet. But now, the specification is pretty much done, and I don't think it's gonna change much anymore. And there's also even an example program already, I've heard. So that's what we're gonna have a look at today. Just how the transfer hook actually works, like what it is, how it works, how does our program need to look like that it can be called. So what's the interface of that program? And we just play around with that a little. And then I will make videos in the future where we do more development on actually building useful functionality with transfer hooks. I have a few ideas, but for this video, I just want to introduce the concept of a transfer hook and give you a vague idea what you need to do to use it with Token2022. So let's get to it. Token22. Oh, that's even a promotion site. Oh, on-chain metadata. This is another great thing. And transfer hooks. Create an ideal user experience. Using transfer hooks, token transfers can be gated by digital assets like NFTs, loyalty cards, and identity credentials. So on their official solana.com promotions page, they talk a lot about authorization, like gating transfers, right? So only NFT holders can transfer tokens or something like that. But you know, it's so much more powerful than that. You can put any kind of logic into the program, and it also has access to how many tokens are transferred from which account to which account, and a bunch of other stuff as well. And we're gonna have a look at that today, what the actual interface looks like. And you can have your custom accounts in there as well, somehow. Yeah, it's a new standard built for businesses on Solana. Yeah, Solana really wants to attract those commercial clients. Anyhow, so that's not what I was looking for. I want to go to the docs. Sorry, because I'm so doxed. Hello, my name is Andreas and I run this YouTube channel. Extensions, transfer hook, my fave. Let's go. Let's talk about transfer hooks. So, the motivation. Let's go over this one more time, a little bit slower. And if you know what it's about, I mean, I have chapters down here. You can skip ahead if you want to. I don't judge. You can do whatever you want. I know that I take a long time, but I want to go into detail here, right? And even if it's just for myself, but I do want all that knowledge to somehow go into my brain and via this microphone and screen to you. Okay, anyway, so why the hell would we want a transfer hook? on our token. High level, more control over how it's transferred, because we can add our custom functionality. Most prominent use case revolves around NFT royalties. Yeah, because that's always something that people want to have. And you can't do NFT royalties with transfer fees. Why not? Because transfer fees have the fee in the token that is transferred. And if you transfer the NFT and there's a transfer fee, then the little fee will be rounded up to the next possible amount of token to be transferred, which in the case of an NFT is an entire token. So as soon as you have a transfer fee on an NFT, the entire token is just taken as the fee. And that's not what you want. You want to enforce royalties like some other token being paid, like Sol or USDC or whatever, but you don't want to have the fee be taken in the token itself. That's why we can use the transfer hook for NFT royalties. I don't know if there's actually an implementation for that already. Otherwise, that could be an interesting thing to do for a future video. Current solutions typically resort to freezing tokens, which requires a proxy layer to interact with the token. Yeah, the whole Metaplex PNFT stuff basically just cripples the token program and pretends to be its own token program. And it's just a mess, needing 5 accounts for you to transfer tokens, and it's all just horrible. I don't like it. Personal opinion here, not to bash on Metaplex. That's just how it evolved, because there were no better solutions back then. But now with Token 2022, we finally have nicer solutions where we can do it so much cleaner with transfer hooks. And then that's the best thing about it. Wallets and marketplaces don't need to be aware of this. For them, it's just a normal transfer where they call the Token 2022 program, and they don't need to know about our program. Indirectly, they'll have to, but that's where that interface comes in. So it is not a simple solution. I'm not saying that, because there's a lot of complexity with, all the accounts that we need for our stuff and whatnot. But at least all of the applications don't need to implement custom logic to support that feature. They just need to support Token 2022, and then all of the custom transfer hooks from all the people are supported. And that's very helpful, because Metaplex had to do a lot of lobbying to get the PNFT standard integrated into the wallets and the marketplaces. Yeah, and then there are different systems and they all have their own, and that just harms composability. So the idea of transfer hooks is make it easy and make it universal, like one standard. I mean, there'll never be a one standard solution on Solana. They'll always coexist. This will not replace Metaplex fully, but hopefully more tokens are gonna use this, just because there's much more freedom to work with this than when you work with PNFTs, which literally is just a blacklist of some exchanges. Anyway, to the solution. To improve the situation, Token 2022 introduces the concept of transfer hook, interface, and extension. So we have the interface part and extension part. The extension is what goes on the token, and the interface is what goes on a certain program that the extension then uses, such that on transfer that program is called. A token creator must develop and deploy a program that implements the interface. Yep, there we go. So interface must be implemented by the program, and then configure their token mint to use their program. And then during a transfer, the Token 2022 program calls into the program with the accounts specified at a well-defined PDA. This is where the complicated technical stuff comes in that I want to have a look at today, how that works. And the call happens after all other transfer logic, so the accounts reflect the end state. So that's also important to note. Our program is called in the end. So first the Token 2022 does the transfer. So all the state updates are already written to the accounts at the point when the transfer hook is called. That's important because obviously we want to be able to check what kind of transfer was performed and if the transfer was even successful. Because if it's not successful, that hook will also not be called. At least I assume that to be the case, because why would it? Transaction gonna fail anyway. When interacting with a transfer hook program, it's possible to send an instruction, such as execute transfer, to the program with only the accounts required for the transfer instruction. Extra accounts that the program may require are automatically resolved on chain. Right, so again, this is where the complicated stuff comes in, because let's imagine that all your transfer hook does is write to an account how many transfers were executed in total. You probably don't want to do that because of bottlenecks reasons, but let's assume that that was your use case, right? You just want one account where you track that. But then you have the problem that you want to write to that account, so it needs to be in the list of accounts when the transaction is sent, but it's not an account that is part of the transfer, right? It's not the destination account, it's not the source account, it's not the token mint, it's your account. And in order for that to work, we have to do some magic, and we'll have a look at that magic today. I'm assuming it's gonna be a long day for me. So my goal for today is literally just deploy a program that is called as a hook. If I manage to get that far, then I'm already gonna be proud of myself. So maybe let's go there first. I'm gonna create a token with a transfer hook. We literally just need to say transfer hook and provide the program ID. That's the easy part. The really easy part. Oh, cool, there's even JavaScript stuff already. Transfer hook program ID, and we create initialize transfer hook instruction for our transfer hook program. Then we initialize the mint. So on the token part, it's really simple because the extension exists and we just enable it. But the complicated part really is then writing that program correctly that is being called. This one. So let's go through the resources, because there's an interface description here with a minimal program implementation. That's what we want to have a look at today. Example program and the interface are powered by the SPL TLV Account Resolution library. So this TLV, this is what we're gonna have a look at, because that's how all of this works, like the account resolution. Maybe look at that first, actually. Library defining a generic state interface to encode additional required accounts for an instruction using type length value structures. That's TLV, type length value. If a program requires additional accounts to properly implement an instruction, there's no clear way for clients to fetch these accounts. Important to note, it's still the client that needs to fetch that account, because again, the account needs to be present in the transaction, which has to be signed. So it needs to be put in at the moment of signing already. But with this account resolution, that can be done on client side. Basically, they just look it up from that PDA and then know which accounts they have to pass in. There are two main ways to fetch additional accounts: dynamic through program simulation, or static by fetching account data. Dynamic through program simulation, I think that's what we've already done before in a video on, well, yeah, transaction simulations. There I was already hinting that that can be useful for interfaces, and I think that's exactly what's happening here. This library implements additional account resolution statically. Okay, it's not what's happening here then. So dynamic account resolution would then be something like the program could theoretically decide dynamically, so when it's called, which accounts it needs. So depending on some state of the program, it might need different accounts. Static means we define it beforehand. Those are the accounts that we need, and therefore they can't be dependent on any program state, because we don't run the simulation again, we don't execute the program, we just have it statically written in some PDA. Okay, so how does it work then though? Static account resolution. It's possible for programs to write the additional required accounts into account data, so that on-chain and off-chain clients can simply read the data to figure out the additional required accounts. Let's imagine there's a transferable interface with a transfer instruction, but some programs may need more accounts. So the static approach requires the program to write the extra required accounts to an account defined at a given address. So this could be the mint or some address derived from the mint. A client must fetch this additional account, read its data, and find out the additional required accounts. So essentially we read the state, we pass it, and then we should know which account we need to include. And then also actually include them into the instruction. Then on-chain, so this is client side, this is before we're in the program execution. And then on-chain, when we actually execute the program, or when the program is executed, program must have access to remaining account infos containing the special account and all other required accounts to properly create the CPI instruction and give the correct account infos. So again, the program then also does the same. It also reads that static state. In our case, that would now be the token program, token 2022, also has to read that account and then pass it and make sense of it to then properly create the CPI with the correct accounts. And then our program is CPI'd into correctly, hopefully. This approach could also be called a static interface. Okay, so I know this is very technical, but we need to go through this to understand transfer hooks, because that's what they need to work. Moving on. What kinds of accounts can we add here in this static interface? Obviously, accounts with a fixed address. If it's always the same account, I can just put in that fixed address. That's fairly easy. Okay. But then we can also do accounts with a dynamic PDA. So an account that depends on some other account, but it must then obviously be derived in a certain way. So the seeds must be given in a combination of hard-coded values, such as strings, right? Like some prefix that is common to be used for a PDA. A slice of the instruction data provided to the transfer hook program. There it already names transfer hook program. So it can be part of the instruction data. So I would imagine something like the amount of tokens being transferred is part of the instruction data and therefore could also be part of the seed. The address of another account in the total list of accounts. So we can reference the mint, for instance, or even the destination account or a source account, or a program ID from another account in the instruction. So I guess the program ID of our program that is CPI'd into, like the target program, I need a good name for that, because there's always the token program and then it calls our program. I'm gonna call it program that got hooked up, the hookup. Yeah, I don't have a good name, damn it. But anyway, that could then also be part of the list of seeds for this PDA. So we're not fully dynamic, we're still static, but the static supports PDAs that are derived. We can't do stuff like, if it's Monday or whatever, then use this sort of account, and if it's Tuesday, use this sort of account. But we can be like, it's always a PDA that depends on the mint and the destination. So the PDA is dynamic, but the interface is still static. The way how it's derived, that is static. That does not change. But the address of the PDA then obviously change depending on the input. Okay, so when you store configurations for dynamic PDAs, the PDA itself is evaluated at the time of the instruction invocation using the instruction itself. This occurs in the off-chain and on-chain helpers mentioned below. Yeah, so obviously we need to derive the PDA on client side first to put it in the instruction correctly, and then on-chain the program will check it again. I think that's what that means. So how it works. The library uses SPL type length value to read and write required instruction accounts from account data. Interface instructions must have an 8-byte discriminator so that the exposed extra account meta list type can use the instruction discriminator as an array discriminator. Do you understand that? Great, me neither. This was a lot of words and like, this can be confusing. Oh, thank you for validating my emotions. Type implements SPL discriminate so that the type can be written into TLV data. Still doesn't make sense if I read that, but maybe for you it does. Then you're smarter than me. Congratulations. I've read it. I don't understand it. Let's go through examples such that it makes sense. See the example code, extra metas. This would be a static account, this one as well. And this one would be a PDA that is derived with the following seeds. First a literal, then some instruction data, and then some account. The second account, so account with index 1 in the instruction, and then probably something like if it's writable, and yeah, another PDA, external PDA. And then we have an extra account meta list add to instruction to this mutable instruction. We add the accounts that we get from a client get account address. First we need to initialize the structure of the instruction. There it then knows which extra methods to take. Then we add it. Okay, and from those extra methods it then knows which addresses to put it, because the RPC will provide that on OK. And if we don't have an OK, then we fail. But that's all done by this library, so we don't really need to. And I don't want to go too deep into that, because really I want to look at transfer hooks, but we need to understand how this works in order to be able to provide the accounts correctly. I mean, we can have a look at transfer hooks without providing additional accounts first, but that's still pretty limited. We do want our custom accounts, so we do want to use this TLV account resolution. And on-chain, so the token program would then add to CPI instruction. This is the off-chain part, this is the on-chain part, which, you know, works similarly. Just that we don't need to do an RPC call to get the info, but we're already in the program, so we can read state. All right, I think it's better to actually work with a program to get this and try it out. Ideally with the transfer hook example. So we already work with transfer hooks. Here's an example program. It only implements the required execute instruction. So that's maybe already interesting to note. The instruction is called execute. So on transfer, the execute instruction of the interface program is called, assuming that the proper account data is already written to the appropriate PDA defined by the interface. So what's the interesting part here? The entry point where we get the usual program ID, accounts, and input. We get a transfer hook execute instruction. So basically what this does, it reads the first 8 bytes and checks that that's actually a transfer hook instruction. So this unpack from the input, you know, our input data, there it will check that the instruction discriminator matches the execute. Otherwise, we will already return, because our program could also do other things and not just be the interface for the transfer hook, because an interface can be implemented additionally to other program functionality. So if there's any other instruction data, it can perform other things. In this case, in this simple example, we just error if it would do something else, because we're just interested in the execute. But obviously our program could do many things and also be the interface. Just allows for more composability, because then that program can access some PDAs that might be relevant. So it just makes it easier that that is by itself its own program. I hope that made sense what I just said. So essentially we check the first few bytes if it's the execute instruction, and then we read the accounts in the following order. So this is how we get them. This is basically defined by the interface, which order the accounts are provided when we CPI into this program with the execute instruction. First one is the source account. So where do the tokens come from? The sending token account, the mint, the destination account, so the receiving token account. The authority info, I would assume, is the sender. So the person who signed for the transfer to take place. So that's the user public key, I assume. And then the extra account matters info, that I think is that account that contains those static references. And we can check that that's the right one for my program and this mint. And if it doesn't match, then we error. Then again, there we do the on-chain part of check account infos for our instruction with program ID, the data, and the accounts, which are all accounts actually. Yeah, so this is what we saw here already. That seems to be another function provided by the TLV library that basically checks that the accounts are provided correctly, so that the remaining accounts that we have in here match what we would expect given in our account. And if it doesn't match, so if the check fails, then this would also error, because we have the question mark here. Only if this says okay, then we proceed. And yeah, that's all this example program does. Here we would then add our custom logic to, you know, do whatever. that we want to do in our transfer hook, but that's then for us to implement. How about this? It's much nicer to learn by doing than by reading source code. So let's get this. I'm gonna clone the entire SPL. So the Solana programming library token transfer hook interface. And I think I'm gonna go ahead and just try and get it to work and then see which struggles I fall into. Because we have an implemented example, let's just use it and then see how we can modify it to do the things that we want to do. But as a first step, I really just want to have a token that I can transfer with a transfer hook. And that transfer hook should just say, hey, the transfer hook was called. Then I'm already happy as a first step. And then we can work on the account resolution a bit more. Obviously, I don't want to just use all of that code and not understand what it does, but you got to start somewhere. Source account, token mint, destination account, source accounts owner or delegate. So that's the authority, yeah. Validation account, and then the additional accounts written in the validation account. So the validation account is that extra accounts account. And the execute has just amount as instruction data after the discriminator. But this thing itself is not a program, is it? This here is then an implementation of the interface. Here we had the interface definition, and here this is the actual program that has this interface. We have the interface and we have the example. Because the interface really is just the interface, and the example is an actual program implementing the interface. Okay, so here we have an actual entry point. Yeah. So in this example program, we have an entry point, process, in the processor, and process unpacks the instruction data and tries to match on execute. Cool. So there are two instructions that we actually implement, the execute and the initialize extra account meta list, which obviously we need to call once to write that account, to create this one static account that can then be used to read in the execute. Because in the execute here, we read the ones that we expect and then also the extra ones from this extra account meta info. And if that thing doesn't exist yet, then we'll probably get an error here or later when we read it here. But the execute, this is what's called on transfer hook. So I said that here I would add my code transfer hook completed. And that initialize extra account meta list expects those. So which one to initialize? The mint, the authority, and the system program, because we want to create a new account. So obviously we need the system program to create that account. Create the account by allocating and then assigning to our program ID. And then we write the data with that init that we get from that library. Our execute instruction with data and extra account metas. Extra account metas that comes from externally. So we provide that here and we provide here. Oh, that's actually via the instruction. So that comes from here as well. So that's part of the input. The input already contains which extra account metas we want to write. So apparently that's also in this implementation done on client side that we provide this. Do we have tests? Yes. Setup. We want the sysvar instructions. We want the mint authority. And we want one with seed prefix and the account with index 0, which would be probably be the source account. Not entirely sure. So in this test, this is what we would initialize it with. And then another one from instruction data. So the amount, index 8, length 8. We want the amount. So we need to say index 8 to skip the discriminator and length 8 because it's a U64. That's how we get the amount as instruction data. I don't know why you would want a PDA with the amount but you can do it. And then index 2, which is probably the destination account. Yeah, sure, why not? Extra account with pub key, a writable pub key. So that's a static pub key that we add for fun. Okay, and then we add those actual accounts. So those are now the actually derived accounts. And then we do exactly that. Initialize extra account meta list. First we transfer sol there. Apparently we also need to do that because all that's happening in here is a allocate and we assign it. We don't call create account, which would also transfer the lamperts there. So we don't ever give lamperts, so that lamperts are given in an extra instruction beforehand. There's probably a good reason why we do it like that, but I can't really tell you right now. Yeah, and then we call that instruction. Yeah, those are all sorts of tests then. Okay, so how do we do this? Because I do want to see results slowly. All very theoretical. I want to actually call that hook. Step 1, get this program to build and deploy it. Can we do that? This example program, can I build SBF this? And obviously, if you build your own program, you probably want to name it differently. But for today, we just take it slow and we take this example program and we want to get something to work. I'm gonna make more videos on that because that's like one of the most powerful things about Token 2022. So there will be more on that, but gotta start somewhere with an example program. And that's a good way to learn, I judge, right? If there is a working example, try get that to work before you try it all by yourself. Cool, we built it. Now we got the target where exactly? Out there in targets? Yeah, there we have it. SPL transfer hook example SO. This one is the one that I want to deploy. Oh, we first need a wallet and stuff. Let's get ourselves a hooker airdrop. Yes, I love it when that works. Another one for the program. Transfer hook interface. There is no capital I. So, Solana, program, deploy the following program ID, the following SPL, transfer hook example SO. All right, that seems to be working quite well. Cool, the program ID deployed. So far, so simple. Step 2, let's create a token. We'll just check if SPL token has all that functionality that I want. Transfer fee, set transfer hook program. So it has the transfer hook stuff. Cool. So we can just do as they say here with create token and then transfer hook. And my transfer hook will be this program. Do I want the name for my token? Nah, never mind. Let's not. Let's just have J1X be my token. Okay. And then the classic SPR token. Create account for this token. Mint. This token. I don't know, 100. And then transfer this token. Receiver 1. Whatever, I gotta do that. And then I fund it as well, probably. Yeah, also fund recipient, whatever. Okay. So, and now is when it starts to get interesting. Error processing instruction 1. This is not nicely formatted, but we get the idea. Instruction get account data size. Initialize the associated token account. So that worked, but then transfer checked. So that's the second instruction. So that's why in instruction 1, the second instruction failed. That was the transfer checked. And the error unknown program, custom program error. Okay, so that's not very verbose, that log. Program log error unknown. Great. But we can assume that it comes from the transfer hook not working correctly. Why does the transfer hook not work correctly? Well, because we didn't initialize that account, that it needs to look up which accounts it should put in here. So let's try and do that somehow. So what we want to do is call this. Oh, there is a SPL transfer hook create extra metas. That will probably make this whole thing very easy for me. Initialize the transfer hook account. There is a SPL transfer hook. Yeah, let's not make it difficult for myself. Do I have that? No. Is that in this CLI here? Yeah, create extra metas is here. Process create extra account metas. Get extra account metas address again with token and program ID. And then basically we parse those accounts that we put in into account metas, calculate the rent, probably do a system program transfer instruction somewhere then. Yeah, here. And then the initialize extra account meta list. So that's the same thing that we saw in the test there, where it creates this transaction with a system instruction transfer and then initialize extra account meta list. That the CLI does here as well. A transfer instruction with the Lamperts, and then the initialize extra account list. So I don't need to write my own script to do that. I can use this CLI. I would have now tried to copy this stuff together, but if there's an existing CLI that I can use, why make it complicated for myself? Let's go build that thing. So go to the CLI in here and cargo build. So now I should have this also in target probably. Def, unoptimized and debug info. Should then be in debug, no? Ah, yeah, there we have it. So here we have the SPL transfer hook in target debug. And I'm just gonna call this. Works, amazing, and it can do create extra metas. It's pretty much all it can do, but yeah. And this thing needs transfer hook program and token mint address, and then I can add the additional accounts. So the additional pub keys required for transfer hook. Should we first try it with an empty list? Yeah, why not? The simplest thing is to provide no pub key and no role. So that would then literally just be the program and the token mint. So program was the th1 and my mint was this one. Let's see what that does. Yeah, cool. We have a signature. We haven't even looked at an explorer today, so let's do that. And here we see that we created this account. First, we just transferred the sol. And then my unknown program did an unknown instruction. But yeah, we know that that's the program I deployed with the interface instruction for initializing that account. What was it called? Initialize extra account meta list. Yeah, the instruction data is quite boring. We give a list of, I think that's the length of additional metas, which is 0, and that's the discriminator for the instruction. And we add 0 additional accounts. But now this account, the for UI, exists. And now that this exists, maybe if I go back here to my transfer, I can now transfer tokens. Oh, so close. Error processing instruction 1 with error unknown. Oh, fuck's sake. Custom program error. They go until 60. Why do I have such a huge error code? In the interface, we also had errors. Oh, that's better. They start at this. That's close. So that's 652, 652. So that's the 1. That's the first. That's the error. Incorrect account. Don't ask me why it doesn't look like it's calling my interface. It does a transfer checked and then an error unknown. And that's all from the token program. That's not my program that's being called. But still, it looks like that's my error. Incorrect account. Let's try with a second program. I deploy the same thing. Let's try it again. Okay, second program is deployed. let's try this thing with extra accounts. So we do the same thing, create extra account matters, but this time for this program, second program, with the same mint, but pub key and role. So we provide pub key and role. Pub key and writable, for instance. Now we provide one of those accounts. So looking at that again, it's gonna look similar to this, just a bit more data. Yeah, we also paid a bit more and we now have more instruction data. One, look at that. There's now the one here. And then that data, which says which is writable, and then 32 bytes for the account. First it says what type of account it is, something like that. But yeah, so that has worked. That account now exists. If I now change SBR token set transfer hook for a token to some other, so set transfer hook for my token to the second program. Oh, maybe they changed it and it's now called set transfer hook program. Yeah, that worked. Look at that. That's probably nothing too interesting. Token program is called with update transfer hook. That's the mint. I mean, we could have a look at the mint account and analyze how that looks like. It's not even that big. So it's the mint and then somewhere we have an extension. 0E is probably the number of the extension. We probably have the authority and the transfer hook program somewhere in there. Something like that. Anyway, question is, can I now that I set the other one do that transfer? Or is it still the same? It's still the same. I keep getting this error. Yeah, I mean, transfer hooks are powerful, but complicated. And especially with this CLI, maybe I build myself my own token transfer. Or I build myself my own CLI. My guess is that it doesn't take the correct account, because it needs to take this account in consideration, but I don't know if it does that. I don't even know how the transaction looks. Like, all I get is this ugly output. Maybe I print myself the transaction. Gonna dump transaction message. Have a random block hash, because that's for offline signing. So I need to provide those things such that it doesn't query them. Anyway, I'm not interested in that. I'm interested in that such that I can look at the transaction, because the CLI doesn't let me do that. And it doesn't let me skip pre-flight checks such that I can just send it to the cluster and then see it in Explorer. So we need to do it that complicatedly. Yeah, I'm getting frustrated with this not working. Let's create ourselves a transaction viewer. Wait, is it base 64? Yeah, that's base 64. Okay, look at that. So the fee pair is BTTMA. Who the hell is that? Because the signer is obviously that guy. I had this problem before that doesn't give me the right. So this is also not helping, is it? Oh, let's see if we can build it like this. All right, so if we do it manually, at least we get nicer formatted logs. We do a transfer checked. We get the error invalid account data. Thank you for formatting that for me. And failed invalid account data for instruction. Okay, I mean, fair enough. I just do a transfer checked and I don't do anything else. I even use the token keg program. So let's do it on the new token program. Same thing. Invalid account data for instruction. But let's say I had another token with the new program. This token, could I then transfer that? No, here also it gives me invalid account data for instance. Oh, because I never created that one. So I can't even send a normal token transfer. Something is really weird. I'm doing something wrong. Okay, but that at least works. Transfer normal to Token22 token. That can't be so hard to replicate, come on. Let's not use that then. Let's create a new transaction instruction. But looking good, actually. See, like that I can send tokens. Don't need no stupid libraries. Okay, making progress. I can send a normal non-transfer hook token. Cool. Wow. Now what if I change that to my transfer hook token again? So now we get the same thing as we had in the CLI as well. A transaction simulation failed with custom program error. This, I'm assuming that we just need another account. That's the one that we created for the second. So that must be the one that we should add. So let's do that. We add this one, writable false, signer false, and then another one, writable true, because that's what we've then written into it. Do I remember what I've written into it? Create extra, this one as writable. So this one. So I would expect that that's how we need to supply this. And the rest I keep the same. Oh, but look at that. We're getting somewhere. The token C is invoking transfer checked, and then at least it's now calling, it's already calling my unknown program, so we're making progress. And then failed, an account required by the instruction is missing. Account required, the instruction is missing. That's what the token program says. Wait a second. But obviously, if I want to call this program, then I need to supply this program as an account as well. And I haven't done that at all. But in which order? Man, I wish there was like better examples or documentation on this. What? Did you just do a transfer? I just got really scared. I'm sorry for screaming. Did that just work now? Am I going fucking crazy after 4 hours of sitting here? Yeah, I transferred. I transferred a token that has a transfer hook set. Transfer checked. I mean, this is wrong because it thinks that's the accounts, but it's not. It's just a additional, that's really the case. So we just have those accounts and this instruction data. The Explorer thinks it's signers, but it's not. It's just the additional accounts that are then needed for the CPI. Ignore that, that's passed wrongly. But the inner instruction, it's my program with an unknown instruction. It's the execute instruction and the amount, which is 1 token. And here we have the program and then my static account as number 6. And the first 5, those are the ones that it expects, like so. The source, mint, destination, authority, and extra. Source, mint, destination, authority, and extra account. Was that account? Yep, that was that one. And then what's written in here is this one. So I also provided this, and then it worked. And now let's check the logs. Transfer checked. Invoking the unknown program. Instruction execute. Transfer hook completed. I can do transfer hooks. So building the program with the example code that we had, easy. That was like pretty simple to get that set up, right? I mean, we literally changed 1 line of code, which was adding this message. The real difficult part was then calling the token program correctly such that it actually has the correct accounts for doing transfers. Because it seems to me that the CLI, at least in version 3.2.0, doesn't do that right. It just doesn't. And even trying to do it with a transfer check, I couldn't make it work. What worked in the end is to build the transaction manually, put in the source, mint, destination, authority, and then the program ICPI into the account where to look up which accounts it needs, and then the accounts that it needs in that order into the instruction. And then it worked. Actually, let me try now if the order is really important. What if I have this account first and then the other? Possibly then it might fail again. Nope, that also works. Order apparently is not really that important. That also worked, which is actually quite weird. What if I had that first? That also works. Even if I have that in a different order, here it's all still in the correct order again. Maybe because the program, it reads from the transfer hook extension in the mint anyway. So it knows which program it needs to call, and then the account just needs to be present in the list of account matters. And it doesn't matter where. You get it. And the same with this account, because that it can derive, right? It knows the seeds to get to this one. And then actually then for all of them, it doesn't matter in which order they arrive. Because there could be several. Yeah, that makes sense actually. The order is not important because it can derive them anyway and then put them in the correct order. So they will always, for this program, then arrive in the right order, no matter in which order I put them here. See, if I have 5, 6, and 7, if they're in a different order, it doesn't matter. Cool, learn something again. This stuff is so cool, I tell you, but it took me forever to get this to execute. And this is now just running the program with a transfer hook. We didn't even implement something interesting with a transfer hook. But yeah, we can now do something more interesting here. Let's say if the amount is larger than, I don't know, 10. So I can only transfer 0.000000000 and so on tokens. You're only allowed to transfer dust, essentially. So this is my dusting token now. 69,420,000. That's my error code. Deploy. We're updating our transfer hook program. And now, if I try to do a transfer, this error originated either by throwing inside of an async function. The send and confirm probably rejects that. But I'm gonna skip pre-flight. Oh, there we go. That looks better. Transaction failed. With instruction 0 with custom error 69,420. And did that make it on chain? Yes, it did, because I skipped pre-flight. We got an error. The instruction failed because my transfer hook failed. And that's how I can, make the whole transfer fail, because my hook has the capacity to do that. That's how I can do royalty enforcement. If I see, hey, the royalties were not paid, I just fail the instruction, and that makes the transfer instruction of the token program fail. Like we see here, transfer not allowed. I'm transferring too much SOL. Too many tokens, because I made that arbitrary rule that I can't transfer that many. So what do we need to do? Well, transfer fewer. So we gotta change my script, and it's in here. That's the amount, and that's the decimals, I think. Something there says which instruction it is, and 00. That is the token amount. If I replace that with, let's say, 0.5, so just 5 millimicro nano tokens, then the transfer should work again. Let's see. Yeah, there we go. Here it worked, because for this one, if I just transfer that little, then my transfer hook says transfer hook complete. I'm okay with this. But as soon as I go over the 5 and go to 11, it will go fail on me. But 10 is still okay. That's fun. And that's the demonstration of a simple transfer hook. I added the functionality that I only allow transfers of less than 11 nano tokens. There. that's still okay. That's the maximum I can transfer in one transaction now, or in one call of the transfer. I could have several transfers within one transaction, but that's what I allow for one instruction call of the transfer. Transfer hook completed. Cool. Okay, but with that, I will leave you now. So yeah, was a highly theoretical video today, but in the end, I also got it to work practically. I just had to manually build this, because if you work with new things, not all the CLIs and stuff are up to date. And that's really the glass chewy part of all of this. Don't worry, it's gonna get better and easier. Probably in a month or two, all of the CLI stuff will just work out of the box. But for now, I had to manually play around with it and get through my frustration and not giving up until it works, which is really difficult sometimes. But I'm glad that I managed and that I can send a token with a transfer hook. I gotta stop here. My brain is already exploding. But we did manage to send a token with a transfer hook. So we did manage to deploy the program that has the interface for the transfer hook. We understand approximately how it works, that we can add additional accounts for that program to use. And we then managed to actually call the token program correctly, such that it has all of the accounts in there, such that it can actually perform the transfer and do the CPI on my program. Oh, wow, was that all difficult? But it's so cool. Just imagine all the things that you can do with this now. If you have your custom transfer hook, you can make it do any sorts of checks. You can implement anything that you want to implement in there. And you don't even need to understand how the account resolution works if you just do some simple stuff. But we do want to build more complicated things, just not today, because my brain needs a break. Holy F, that was exhausting to get it to work. But the overall concept, super great. I love transfer hooks. I absolutely, I'm excited about this. And I'm definitely gonna make more videos where I build some cool stuff with it. And we're gonna learn more about transfer hooks, because for now we just scratched the surface of what's possible. And we still don't understand some things, but we got an overall idea of what it can be useful for and how to set it up. If you wanna create your own Token22 token with a transfer hook, you now know how to, but there's definitely more to learn and more to explore. So make sure to subscribe if you haven't already. Like this video, watch something else in the meantime, and I will see you in one of my next videos where we're gonna dive in deeper to the transfer hook extension. Oh, yeah, wow.